All right, this is another example that I want to do, the integral of e to the x sine x dx. This one is different from what we have been doing so far. What we have had were some trig functions, the sine x or cos x multiplied by a polynomial, or the natural log function multiplied by a polynomial, or the inverse trig functions like tan inverse of x, sine inverse of x multiplied by a polynomial. But this is different. So we will do this example, and I'll add one more like this in the next video. So I'm going to let u be e to the power of x and dv be sine x dx. Let me divide this. Perhaps I might need it. So I'm going to let u be e to the x and dv sine x dx. I should say here that you can start by saying u equals sine x and dv equals e to the x dx. There is no advantage in me choosing the u to be e to the x or the other one, sine x dx. I mean, I could have had sine x. It works exactly the same, whichever one you choose in this case. Okay? So let's calculate du. Du is e to the x dx, and v, antiderivative of sine x, is minus cos x. So then the integral of e to the x sine x dx is the integral of u dv, which is uv minus integral of u du. This is uv, so u is this, v is this, so I'm going to multiply those two. Let u be minus e to the x cosine x minus the integral of v du. Okay? So v du. E to the x times cos x with a minus. The minus will make this plus. So I have e to the x cosine x dx. Okay? Now we have this expression to integrate. Well, let's continue doing a u dv again. All right, let's see. So to compute the integral of e to the x cos x dx, we let u be e to the x and dv be cos x dx. I should mention here that had I chosen u to be sine x and dv e to the x dx, then at the second step, I would have to choose u to be the trig function and dv to be the exponential function. Don't switch up. When you switch up, it'll get you back to where you started, and you're just simply looping back to back to square one. Okay? So stay with the trigonometric function or the exponential function for u and the trig function for dv, or the other way around. Stay with the trig function for u and the exponential function for dv. That's how it works. You can try it. You can try and see why it gives you 0 equals 0, or e to the sine x equals e to the sine x. E to the x sine x equals e to the x sine x. Okay? So differentiate u and dv, integrate, that gives you sine of x. So the integral of e to the x cos x dx is uv, so that would be e to the x sine x minus the integral of v du. That is really, let me put it here, minus integral of sine x e to the x dx. So my original problem, the integral of e to the x sine x dx is, this original problem is this expression, minus e to the x cos x plus this integral, which is this expression. plus e to the x sine x minus the integral of e to the x sine x dx. Let me relax this a little bit. Let me see if I can change this. This integral equals minus e to the x cosine x plus e to the x sine x minus the integral of e to the x sine x dx. Okay? Now, let's see our progress. Okay? We started out with this expression. In the middle, we got this expression to integrate, which is not worse, no better than the original expression. And now we did one more step. We ended up getting this expression, which is actually the same as the first one. Actually exactly the same as the original expression. So it looks like we haven't made any progress, but we have. I'll show you the trick now, okay? There's a little trick that we use here. In this case, we will add this integral on both sides, okay? We add the integral of e to the x sine x dx on both sides. Okay? Both sides of the equality. So that this, we're going to bring it to the left side, because that minus, when you add, in other words, you're bringing it to the left side of the equality. Okay? So let's do that. So I have integral of e to the x sine x dx plus e to the x sine x dx equals minus e to the x cosine x plus e to the x sine x. But when you add these two, you're getting two copies of e to the x sine x dx, which is minus e to the x. Let me rearrange this so I can have the minus in the middle. So I have e to the x sine x minus e to the x cos x. Okay? Well, I don't have to integrate anymore actually. I have to just, all I have to do is divide by 2. So let me just stick a plus c here, because it's the integral of some expression. So the integral of e to the x sine x dx is actually 1/2 of e to the x sine x minus e to the x cos x plus the integration constant c. So that's how you do this problem. Let me recap just quickly, okay? I started out with e to the x sine x to integrate. So I tried to use a u dv, integration by parts. So I have u and dv. When you multiply them, it gives you e to the x sine x. So I'm okay there. Differentiate u and find v by anti-differentiating dv. So once we put the things together, using the integration by parts formula, we end up getting a similar expression as the original. So we have to do one more u dv, but we have to be careful to take u to be the same type, in this case e to the x, and dv the same type, in this case the trig function. Okay? If you started out doing the other way around, that's fine, but make sure you have your u to be the trig function and dv to be your e to the x function. Then calculate the integral of this piece, which will give you that expression to integrate after one more step. Okay, so that's the integration that you want to that you end up getting. However, if you bring this up to this side, if you add that, then you don't really need to integrate it, because you have the expression, the integral on one side, twice of the same thing on the left side. So just divide by 2. That will give you the integral. Okay, so the integral of e to the x sine x becomes this expression. All right.